Good afternoon, everyone. Thank you so much for having us here this afternoon. I just want to firstly thank Julian for arranging such a wonderful program, the corporate sponsors for being involved, and a special thanks to our mentor as well from Airlab. It's been a fantastic program. So for this afternoon's agenda, we'll just take you through what we've been doing here. So basically, we're addressing the problem statement and we're aggregating met data, modeling that data for the avoidance of delays in and around the and so for the agenda this afternoon, we'll go through just some brief introductions. We'll talk about our capabilities so you can understand how we can address this problem statement. We'll talk just briefly on our client references so you get an understanding of how we've done this before. And then we'll really go into that problem statement for you, so how we'll be resolving that. And then we'll open up for questions at the end. So without further ado, just a really brief introduction to the team that's been involved in this accelerated program, been working on this. You can see myself, Phil, based in Singapore for almost 8 years, the managing director, Nadav, and then Omar, our solution engineer, who is a pilot himself. And then from our consortium or partner, we've got Skysquitter, so Julian and Rui. So Julian being a pilot and Rui being an air traffic controller. So depth of experience working on this, guided by it. And so it's two teams, but yet one solution. And so from the Tomorrow I/O side, we're aggregating that data, we're using that data then to provide a forecast, and then we're providing that in a meaningful manner to those stakeholders using that information. And then for Skysquitter, they're able to actually obtain the MODES data from the aircrafts in and around the airspace there. Then they're able to calculate that data, what is the met data from that MODES, and provide that in a database that we can access that for our forecasting. So really exciting and really great collaboration there to resolve that problem statement. So just really briefly, because I know Sheila instructed people want to understand a little bit more about the startups working on this. So you can see our core capability is really around big weather data sets, then leveraging high-powered computing with our own proprietary modeling to forecast out into the future, and then really importantly, making that easy to understand and digest. And you can see there we have global offices, Series D funding up to $190 million, and some key aviation clients that we're working with. Skysquitter, they're the specialists in aviation surveillance. So based out of Germany, and are able to actually retrieve and decode that MODES data. So they'll share a little bit about their capability shortly. So in terms of our capabilities Tomorrow I/O and why there is a nice fit to this problem statement. So the first thing is about being able to obtain large sets of atmospheric data. And so including that MODES data. And we have the ability to ingest other forms of data from local Met offices and also proprietary ability there. We then have our own proprietary models to forecast out into the future. So to understand the weather impact on flights in a certain time horizon. And then it's really insights. So rather than just saying, what is it? Is it a storm? What impact to a specific type of aircraft? So really, narrowing it down and making it really impactful there, which has an impact on both the operations and revenue. And you can see here, I'll show this a little bit later, but this is how we surface up that data. So in a really easy way to interpret. So an insights dashboard by location, by job function, an interactive map so you can understand weather, and then also weather impacts many stakeholders in an airport. So really having technology to automate the decision-making and communications adds a huge amount of value to a very complex supply chain in and around an airport. And we know that you're looking for partners, so it's not just what we're doing now, it's also what we're doing into the future. So we are truly committed to the weather industry, so much so that we've launched our own space initiative to get direct sensing radar satellites to give us global coverage and to resolve some of the challenges that are facing in the weather industry as we know. So I'll just briefly pass it over to Julian just to touch on Skysquitter's capabilities and some of their client references.
Yeah, thank you very much, Phil. And hello, everyone. My name is Julian, co-founder of Skysquitter, and we'll just give a brief overview about our contribution to this project here. Skysquitter is providing a completely new meteorological data source. So we are calculating wind, temperature, barometric pressure, and also turbulence information out of Mode S transponder data. So basically, we're using thousands of aircraft traveling above our heads every day as sensors, but without the need of any additional onboard equipment and without any environmental impact. This gives us precise information about the present weather in the aerospace, in the airspace, and also real-time information about the ground truth. So the actual meteorological situation at the position of the observed aircraft. Moving on to the next slide. There we can see just a simple visualization of our work from the last weeks during the program. We took the radar data stream provided by AirLab to us, and implemented it to our systems, and we can see some wind readings as well as temperature readings here in the vicinity of Singapore. Of course, this is an MVP; it's simulated data, but we expect it to be live further down this year. Because it's an MVP, I attached a small picture on the top left corner where you can see actual real data from our operational network in Europe. This is real data and contains all the information I was talking about prior to this slide. And this data can then be fed into existing systems, for example, weather services like Tomorrow.io in our case. And it can also be used in the context of aircraft operators as well as air navigation service providers to gain efficiency. So moving on in the agenda, we got some information about our client references. So on behalf of Skysquitter, we are active right now at the German and the European market. We work together with, for example, this Swiss military, as well as some air traffic management consulting agencies, and also air traffic control hardware suppliers. On top of that, Skysquitter is still active in several research projects and programs within the technical universities of Germany. Thank you very much. I give it back to Phil.
So for Tomorrow.io, I've selected a couple of the aviation customers that we work with. So firstly, JetBlue. So we really helped them. They looked at storms and then other weather parameters that were impacting their operations there. And really looking at those operations that were impacted by weather, how they needed to make decisions around that. And there were specific ones around high winds, opening and operating of the ramps, and then also because of the winter conditions there, understanding the de-icing protocols there. And we were able to save them by driving efficiency of up to $50,000 per site per month. And then Aeromexico, a little bit more closer to this type of weather situation here. We're able to help them by providing them weather across their network and our technology. And in doing so, we're able to drive a 50% reduction in delays. And what that meant, that was a very fast payback for them, faster than actually pre-COVID times that we were anticipating. So really powerful there. And then on top of that, there was other use cases. They could understand their load balancing based on barometric pressure and so forth. So very powerful use cases there. And so then just going on to recap on the problem statement here. So for us, leveraging big data and then aggregating trusted sources of data to then really drive efficiency and minimize delays around Changi or flights coming into Changi. And we understood the importance of this because we know that weather plays an impact in over 25% of the plane aircraft delays. And of that, just slightly more than 25%, a third of those are derived or caused by thunderstorms. So that's why in this program, through the mentorship, we've been very focused on that. And so to solve this problem, what we did, we looked at our existing suite of products. So how could we enrich that with data from our partner in this, Skysquitter, providing us direct observations from aircrafts around that area there. Then looking at our current models, and then also enriching that with other data sources. And so we have a real-time forecast. We have where Skysquitter data can be fed into. Then we now cast that out into the future. So minute by 3 hours. So that would be really powerful in that first part of that problem statement definition there. And then we also have our own numerical weather prediction model. Once again, where we can feed in those observations from Skysquitter, and we can provide a very high resolution, both temporal and spatial, to overcome some of those challenges in terms of convective weather in this particular region. And then a prototype product that we will, we have patents on that we can build out, and specifically looking at the movement of storm cells, which once again is looking at that sort of slightly longer time horizon to solve this particular problem statement. And so then lastly, how this can be used in the environment out there in Changi. So we see it, firstly, the pilots, because that's what we were focused on for this problem statement. So they can quickly understand what is the weather in Changi at the time that they intend to land there. So they can really understand the weather and they can do their planning around that. They can also then use it for real-time decision-making on route, looking at safety, and then also customer experience. But there's other stakeholders in that environment that can leverage this data as well. So you can look at the dispatchers, so understanding the weather there and making decisions accordingly. And then also the airport, very complex operations there, many stakeholders in there, many functions. So having information plus automation technology drives a lot of efficiency. So I realize we're close on time. I do have a demonstration video that I can share afterwards, but I'm more than happy to open it out to questions now. Thank you very much.
Thanks, Phil. Maybe any questions from the floor over here? I think on Zoom, we don't have any questions at the moment. All right, so if there's any question, okay.
Curious, you have a global climate model which you use for your weather model, right? And then you mentioned you have a numerical model. So is that a regional climate model or is it a downscale?
So we have access to global models, proprietary models that we do downscale. And then as part of this accelerator, our mentor has been helping us to connect with the NEA, and they have a regional model. So with a potential private corporate partnership, we could ingest that model. So our technology has been built on the capacity to bring in more and more observations and models to give a more accurate forecast.
I think we have a question from Tony. He's asking, which weather model do you use?
So we have a combination of models that we have. So we have our own proprietary real-time model. We have our own proprietary nowcasting, which is in that short-term horizon. We have our own numerical weather prediction model, which we use on a specific domain. And then we use an ensemble approach for global modeling out to a little bit longer.
Okay, thanks, Phil. I think with that, we'll move to the next startup. Thanks, Julian, as well.
Thank you.